Hello everyone, welcome back to another video, and in this video I'll be showing you yet again more websites that I like to use, but these websites are not for geologic maps, but for data analysis. A lot of these websites come directly from the USGS and they deal with monitoring data such as earthquake data, volcanic activity data and monitoring, and a little bit more. So I'll give you a good handful of the websites that I like to use for looking at live data when it comes to these things. So let's get right into it.
All right, starting off with the first map. This map is by the United States Geologic Survey, the USGS, and shows earthquake locations as well as other information such as their magnitude. Most of the websites I'll be showing you related to monitoring of the Earth involve earthquakes. There's a lot of different, or a good handful of different websites that I use for looking at earthquakes, this one being number one. So starting off, you can see there's a couple of orange dots on the map. So these are, in fact, earthquakes. And if you click on the gear icon up here in the settings, you can, change the settings, of course. So right now it's set to 1 day magnitude 2.5, but I want to see all the magnitude, so I just simply click this button, and now it's showing me all the earthquake information. As far as the colors, if you were to go to the key here, the map legend, it'll give you all that information. So the bigger the circle, the larger the magnitude. Color shows you when the earthquake occurred, as well as if it's actually an earthquake or something else, and so on and so forth. So if we zoom in here to Washington, you'll see there's been a couple earthquakes. And here, this was a 2.6 magnitude earthquake. It gives you, the magnitude, gives you the time, GPS locations, and the depth of the earthquake right here. If you want more earthquake details, you can click the link, which will take you to some more information. So this is a felt report. So if you think you felt this earthquake and you live nearby, you can just simply click this, fill in the report, and it'll add to the data. So about 10 people have reported to the USGS about feeling the earthquake. You can click here, the Did You Feel It map, and you'll see that it's organized by, I believe, zip code information. So all these little squares are where people were reporting in feeling the earthquake. And I believe they use this data to get more information about the earthquake instead of just relying on seismic data completely. But there's all kinds of different ways to look at the data if you're interested in that. I'm going to go back to just the regular earthquake stuff. So if we click the origin, you'll see that there's some plus and minus data if you're interested in this. This is with uncertainty. So you'll see there's a little bit of depth uncertainty and location uncertainty. And with this earthquake, they have a pretty good idea where it happened. And they have it narrowed down pretty well. But other earthquakes, they may not. And the depth and location uncertainty can increase depending. So going back to the map here. So this website shows earthquake data worldwide, but you're only going to get magnitude 4.5 and greater for the rest of the world. So you'll see there's an earthquake in Iran today as far as the date of recording this video, which was the 5th of October. You'll see it was a 4.1. So let me correct myself. Apparently anything greater than a 4.0 will pop up worldwide. But if it's in the United States, then you can get magnitude data that's actually smaller. You'll see that these red ones have just occurred in the last hour. And then, of course, you have Hawaii here and Kilauea volcano. Speaking of volcanoes, you might have heard about the activity at Mount Adams. So if I click here, I can actually change it to satellite, and that way you can easily find locations you're looking for. So here's Mount Adams. You'll see there's no earthquake data. Now, if I click 7 days all magnitude, you'll see earthquakes that have occurred in the last 7 days, and you'll see that there's none there. However, if I do 30 all magnitudes, there's our earthquake data. So there's been about 6 earthquakes that they have narrowed down actual locations for. However, at Mount Adams, there's only one seismometer actively monitoring the volcano. So due to that and the small scale of the earthquakes, they're actually going to be putting more seismometers, at least for a time, to get a better constraint on what's happening. I don't believe these earthquakes are magmatic, but I have another website that I'll be showing you in this video for volcano monitoring, so I'll get to that eventually. But since there's only one seismometer, I believe the origin for these and uncertainties should be quite large, and they're not, so I'm going to pretend I never said that. You'll see I still left it on 30 days all magnitude. This kind of gives you earthquake activity in the past month. Up here off the coast of Canada, they had a 6.5, pretty good size earthquake there. You'll see that sometimes they'll have tsunami information. This one in particular did not cause a tsunami, but since it is large enough, another cool feature you might be interested in is this thing called moment tensors. There is a way to read this. I'm not sure if I'll go into it in much detail with this video. So this cross point here in the line, that's the location of the earthquake. And when you see a cross like this and you have the color here, basically when you have color right here, that means the wave is going this direction and the wave is going this direction, and it's, I believe, compressing inwards from in the white. Anyways, this style of moment tensor, this shows that it was a strike slip type fault, a shearing fault, side-to-side motion. So these typically don't produce tsunamis. So the different lines here represent the two possible fault plane solutions. So I believe it was likely this one here, since that is roughly in line with the major tectonic plate on the map. But if we go to this 5.1, I'm going to believe this is a normal fault. Yep, see how now we just have this big white space here and two darker colors on the edges. This is typical of a normal fault type earthquake. Now, if there was color completely in the center and it was white on the edges, that would represent thrust fault or reverse fault. Or if it was just completely colored on one side and not the other, that would also represent thrust or reverse faulting. Basically compression style earthquake. So that pretty much wraps it up for this website. There is actually one more thing I want to show you real quick that you can do. You can do this earthquake catalog, and you can look at past earthquake information. So I'm going to just put in 1990. We're going to go as far back as I can. I'm going to put the magnitude all the way down into the negatives to make sure we get a good representation. You can also go to advanced options, and I'm going to make event type just earthquakes, because that's all I'm interested in. You'll see there's a lot of other information you can get from this. I think they even have nuclear testing on here too. Yep, nuclear explosion. So if you were interested in all the nuclear explosions that have been recorded, actually, let's do that for fun. Let's check that. I'll leave that for now. So you can draw a rectangle on the map. I know one place that typically likes to do nuclear testing, or has in the past. So you can click and drag over the area, use this region, and then you can go down to search. And sometimes it takes a while to load in. Yeah, see, earthquakes loading. There we go. So some of these are going to be earthquakes. But you see this big triangle. Remember, in our legend, diamonds, not triangles, diamonds represent non-earthquakes. So if we click this, 6.3 nuclear explosion in 2017. So in North Korea, at the time, they tested nuclear weapon. They also did the same thing in 2016. They apparently did 2 in 2016. So that's how they can figure out what countries are testing nuclear weapons, through seismic data. So let's go back to earthquakes. So if I modify the search, let's leave North Korea. I'm going to turn that off. Let's go to good old North Idaho, where we have the Purcell Fault. This is a fault that I might have mentioned in some past videos, and I would like to talk more about in the future. But this is a large normal fault and detachment fault system. So let's look at all the earthquakes that have occurred in North Idaho. You'll see the yellow ones have occurred recently. These gray ones are several months old to many years old. This one occurred in 1989. But this is a good way to look at historical earthquake data, as well as get information. And fun fact, this swarm right here below Lake Pend Oreille are some of, actually, the first earthquakes I ever felt. I believe it started with this 3.7. Where is it? That's the 3.9. That was the second earthquake I ever felt, which came just hours after the first. That was an interesting one. It came quick and was a kind of a quick jolt with a deep rumbling sound. Here's the first one I felt, which was a 3.7. This one was more like a convoy of trucks driving by, and it lasted about 10 to 15 seconds, and things were kind of rattling a little bit, and then that was it. Really cool to experience that. And then we've had some others, such as this 2.8 that happened in 2020 that I actually recorded with my Raspberry Shake seismometer. But this basically wraps up this website for the latest earthquakes by the USGS. So let's move on to some of the other ones by the USGS. So this is the same website essentially, but these are scenario catalogs. So if you're interested in seeing earthquakes that can happen, this website's for you. So you'll see there's a good list here. Let's go to Montana scenarios. So you click Montana scenarios, it gives you the view catalog on the map here. And you see all these red dots. So these are scenario earthquakes that potentially could happen. So you'll see up by North Idaho, we have the 7.0 scenario earthquake at the Savage Lake Fault. You can click on it to get more information, and they should have shake map information on here as well. It's taking a little while to load in. There we go. So there's the shake map. So this will show you how intense the shaking would be. So if I was in North Idaho at the time of this earthquake, I would feel strong to potentially moderate shaking. It would probably be on the strong side. While if you're right here in Montana near the epicenter, well, you're going to have very strong to potentially violent shaking. Here's more of an interactive map. So you'll see that this is a 7.1 or 7.0 earthquake, but if we click here, it would almost feel like a magnitude 8 earthquake, and that's likely because this whole valley here is probably full of glacial sediments. And when you live on sediment-based landscapes, that actually amplifies the shaking and makes it worse. If your home is in the bedrock, like up in the mountains, the shaking is going to be less severe. So that's likely, you'll see near Mount Spokane area, this is all bedrock, right? So the shaking is going to be a little less intense than here in the valley, like in Athol, where it's potentially going to feel like a magnitude 5.5. So these are scenario earthquakes. If you're interested in checking that out, apparently they can have a big one way out here in eastern Montana. That's kind of crazy. So they have all kinds of different scenario earthquakes that you can look at, not just for Montana, but for other states, especially the west coast here because of the Cascadia subduction zone. You'll notice that these red lines here, these are faults that they have mapped on here, but not every single fault is obviously mapped, just some of the major ones. You'll notice the Purcell fault, which caused the earthquakes I felt, is not on this map. But, yep, this is the scenario earthquake catalog by the USGS. So let's move on to some of the other maps real quick. So this is another website used for looking at earthquakes. I'm not going to talk about this one hopefully too long. It's pretty similar, except it automatically tends to give you historical earthquake information. So as I zoom in, you'll see there's a lot more dots right off the bat. Something else you can do, you can also put in time range. So if you're interested in a certain time range, you can do that. You can increase the maximum amount of earthquakes shown on your screen. You typically have to have a strong computer to run this much. You'll see it says caution. It's going to give me a warning if I hit apply, or it should. Did not, so no issue there. But I can do the maximum amount of earthquakes on my computer. You can also sort from largest and newest. But what's really cool about this website that I like, you can enter a 3D view. So if I click this 3D view here, it generates a 3D view of the entire map, which is pretty cool. So I'm going to exit out of that for now. I'm going to zoom in. Apparently I need to use control. Zoom in right here to North Idaho. You can also select a region. So you'll notice that Lake Pend Oreille area is only showing a few handful of earthquakes, but if I select the region, it's probably going to show more. Yep, now it's only concentrating all the earthquakes in my box, so it'll allow more details for a specific region you're interested in if you're interested in that. You can also enter a 3D view and see the earthquakes in 3D and their relative depths, which is really cool when you go to volcanoes and the subduction zones. So let's go to Mount St. Helens, a volcano that has an active past. So if I deselect the region, because I still, I just zoomed way out on accident there. Let me zoom back into St. Helens. So you'll see there's a lot of earthquakes popping up at St. Helens. Pretty typical. It's a volcano. But if I hit the region button and select it, you'll see there's going to be a lot more. So this is going to be showing all the earthquake data that they have from the past up to the present. But what's really cool is if I enter the 3D mode, and you can see you can adjust the size of the box quite easily by clicking and dragging it. So I'm going to enter 3D mode now. And this gives you a really cool representation of the magmatic system below Mount St. Helens. It almost looks like roots stretching down into the earth. You'll notice that there are dots above the map, and these are earthquakes that have actually occurred above sea level and in the mountain. So I believe this plane right here should represent sea level. So everything below the plane is below sea level, while everything above is, well, above sea level, but in the mountain. So this kind of gives you a good idea of where the magmatic system is and how it travels up through the earth and potentially where the magma chamber is. So seismic information can definitely help you visualize where magma paths are, but there's a lot more to that than just seismicity. Real quick, I want to show you a subduction zone. I would use the Cascadia subduction zone, but I think it's better to see it either in Alaska or South America. Let's go to South America. Let's use Chile. This is where we have subduction. And if you're not familiar with what subduction is, that is where the oceanic crust is actually being pulled and subducted underneath continental crust. You'll see all these colors. The colors this time, instead of representing the days that the earthquakes occurred, this represents the depth. So the brighter the colors, the deeper down the earthquakes have occurred. You'll see the legend right here. So these red ones are extremely deep. They're deep in the mantle. But if I put it in 3D view, we should be able to get a perfect visualization of subduction, which we do for the most part right here. You'll see that we have these surface earthquakes. These are earthquakes that are occurring within the continental crust. But you'll see we have these earthquakes that are arcing down. This is a good way to visualize the subducting slab as the oceanic crust slams into the continent and subducts and sinks down into the mantle. So you can actually see that in this view. And that process, of course, is what generates volcanism and volcanic activity near these subduction zones. So this pretty much wraps up this map. There's a lot more things you can play with, but I'm going to move on to the next earthquake map. So this is called Seismic Explorer. It's another cool way to visualize earthquakes, and it does so by creating a timeline that you can play and restart. And it's basically a good way to visualize all the earthquakes that we have recorded from the past, starting in 1980 to present. So I'm just going to let this play out for a moment. And you can see there's all kinds of little dots popping all over the place. So the bigger the dot, the bigger the magnitude. And the color, I believe, once again, represents depth. So these blue ones are deeper than the red ones being surface. So it's opposite from the last map, I believe. But you see it just played out. And you'll notice there's no earthquakes in North Idaho. But if I zoom in, just like the previous map, it's going to load in even more detail if you're more zoomed in. So if we go to, let's go to Hawaii this time. So if you remember, Hawaii had the big Kilauea eruption in 2018. And this is a good way to visualize how it happened. You'll see there's quite a bit happening underneath the summit of Kilauea. So I'm going to let this play out, starting from 1980. Oh, I have to hit restart. There we go. See just some normal little earthquake activity. And it was constantly erupting since 1983, up until the end of its climax in 2018. And you'll see how quickly things took off from there, and now we're at modern times. Just in a blink of an eye, we covered multiple years. It also has a cross-section mode, so if I want to take a cross-section of Kilauea, I think I have to drag it, there we go. Everything in this box will now, we can create a cross-section of, and I can also open in 3D view. But unlike the other one, I don't like the 3D view of this one on this website, because you'll see we go all the way down the depths of 800 kilometers, and since everything is so close to the surface here at Kilauea, it just looks flat, so you don't really get that much detail, and as far as I know, you cannot adjust this setting. So if you really want to look at earthquakes in 3D, I would suggest the previous website that I talked about. But this is good for looking at subduction zones. So let's go to Alaska this time, because subduction zones actually do go deep. So let's open this in 3D view, and it should look a little better. There we go. So once again, you can kind of see that shape of how the oceanic crust is actually subducting. And this pretty much wraps up this website. There's not really much more to talk about. That's basically it. So let's move on to another website I like to use. So again, sticking with the theme of earthquakes, except this is the Pacific Northwest Seismic Network. So this is going to show mainly earthquakes around the Cascade region and parts of North Idaho and Northern California and Nevada. You'll see right off the bat, we have earthquakes near volcanoes. So this is showing earthquakes at volcanoes in the past 30 days. You'll see that Mount St. Helens, of course, is just dominating the amount of earthquakes that are occurring. Mount St. Helens is not active and erupting, but earthquakes are pretty common at that volcano. It is the most active volcano in the Cascades. Second being Rainier. And then Adams usually is not on this list because typically Adams only has an earthquake every 1 to 3 years, one earthquake, that's it. So the 6 that it's had recently is pretty unusual, so that's why it's getting some attention. And you'll see that we also have Hood, Baker, and so on. Then it shows you most recent earthquake locations and their magnitude. But what I really like about this website is it allows us to look at seismometers as well as seismic data. So if we click map, it'll show up a map of all the seismometers in the Pacific Northwest, related to the Pacific Northwest Seismic Network, of course. So I'm going to let's click on one at St. Helens, right there in the crater. Let's view the seismogram. Viewing the seismogram, you can now see the live data. So this is all data that is being recorded today. Where the line stops, that is real time. So if I was to refresh the page here in a few moments, which I'll do when I'm done explaining this, you'll see that the line should now be extended. So I'm not going to go into how to read the seismometers. That's something I'm actually still learning about myself, but I do have a basic understanding of how they work, and I can kind of read it for the most part. So all these squiggly lines you see here, that's some kind of noise. And noise comes in many forms. Seismic instruments can record things in the air as well as the ground. So all of these things, this could be things from wind, it could be rocks. Since this seismometer is in the crater, having climbed Mount St. Helens myself, I saw firsthand how unstable the crater rim is, and there were rocks constantly tumbling and falling into the crater. So some of these signals could be from that, could also be helicopters and other things. But you see these really sharp signals here? These signals, these are actually earthquakes. So these are rock-breaking events. This does not mean that the volcano is going to be erupting anytime soon. This would be considered for Mount St. Helens just background information. Now, you'll see that there's about 1, 2, 3, 4, 5, 6, 7, 8 of these nice sharp ones. There's been about 8 possible different decent earthquakes, potentially around Mount St. Helens, and maybe some smaller ones. Now, things would only be concerning if you saw these really sharp signals and they were taking up 80-90% of the seismometer. That would tell us that things are ramping up and maybe the volcano is getting ready to reawaken. But right now, everything looks normal. So I'm going to refresh the page, and this little line right here should now be extended past the 5. Or not. Okay. Proving me wrong again, but it does refresh. You'll have to take my word for it. And it shows you the current date. So if we look at the date here, you can actually go back to past dates. So if I want to look at the same time, but let's say in 2006, I don't know if the seismometer was around that long, probably not. So there probably won't be anything. Yep, we probably went way past its time. So let's do, 2020, everyone's favorite year. No image, okay. But, all right, we'll do 2023. We'll do last year. There certainly has to be data from last year at this time, yep. You'll see it looks completely different. It'll also mark earthquakes sometimes that occurred nearby. So this 2.8 that occurred. But that's pretty much it for the Pacific Northwest Seismic Network website. There's a lot more stuff you can look at here. You'll also notice up here at the top, we have volcano seismicity. So you can look at volcanic seismometers and earthquakes at volcanoes. But I'm going to use a different website for this, so let's move on to that one. So this is yet another website by the USGS, but this is specifically for their volcano hazards page. So this shows all the volcanoes that the USGS is monitoring. You'll see that they're color-coded. White ones are not monitored and they're unregistered. Green ones are monitored actively, and green means that they're at normal background levels. Yellow represents unrest. Orange with an I, like up here in the Aleutian Islands, means it is at alert level watch. Red would signify an ongoing or immediate eruption. So if we scroll down, you'll see there's all kinds of information here that you can look through on their website. They also have up-to-date volcano updates. So if volcanoes such as Kilauea or other volcanoes are starting to act up, they might have monthly, weekly or daily volcano updates depending on the situation. So if we go back to the map, I'm going to actually zoom in here. And as we zoom in, we should start seeing more information. So here we have Mount St. Helens, Mount Adams. Let's zoom in to Mount Adams. You can also click it, and then you can go to the Mount Adams website. And this will open another tab. And this is specifically for Mount Adams. And you'll see there's only one seismometer currently at Mount Adams, which is soon to be changed due to the recent activity. If we click this seismometer, you'll see the data in the past 24 hours. Looks like there's a lot of noise on here. That right there could potentially be an earthquake, but it's hard to tell with this type of data that we have to view here. So let's instead go to Mount St. Helens. So if I click St. Helens, there we go. You have to click it just right, apparently. You'll see there's a lot more going on here. So triangles are seismometers. The stars are our GPS stations. So GPS is going to record the Earth and its movements. So if there's any kind of disturbance or movement tectonically or from magma intruding, that's going to make the Earth move, and these GPS stations will record that information. You'll notice there's a little cloud here. That's a gas station. So let's click that. And they don't have this at every volcano, but they do at Mount St. Helens. I actually saw it in the crater. It's a little box, and it sits near one of the fumaroles on the lava dome, and it just records data. So it has all kinds of information, but it specifically records the gases that are coming out of these fumaroles, as well as the temperature, which is somewhere around here. It has air temperature. There we go. There's the vent temperature. And you'll see that it's pretty steady, right about 96 Celsius, I would say. These drops here, that's likely an error in the machine. If it's not reading right or some kind of error happens, it'll look like this. The temperature, then it just randomly drop to, what is that, like 50 degrees Celsius on this day, and then just go back to normal. These are errors because the machine maybe wasn't sending data that day. Maybe there was a heavy storm or something in the volcano or cloud covers. Something caused the data to do this. So this is an error and should be ignored. You can also look at sulfur dioxide, which the sulfur ratings are pretty much right at 0, so nothing's changed. We also have past month carbon dioxide, which you see has fluctuated a little bit throughout the days, but everything looks pretty much normal. But let's click some of these GPS stations. This GPS station I actually walked right past while I was summiting Mount St. Helens. So let's look at what it's recording. So again, the sharp, really high points are probably errors. This straight line right here probably represents when the GPS station was offline for maybe a couple months or so, or days. And when it reactivated, you'll notice that it just drew a trend line to show the general trend that it was heading in. So this top one shows east, middle north, and the bottom one up. So east, if this GPS station was moving towards the east, the line should be trending up in this direction, but you'll see it's actually trending down. So this means the GPS station is moving westward. And this gives you the speed at which it's occurring. Oh, there's the time frame. So this is back in 2006. So this is many, many, many years of time. So these actual little ticks here, actually, these variations, at this time, Mount St. Helens was active and erupting. So it was building a lava dome from 2004 to 2008. So these little variations here actually could be related to the volcano. I'm not sure what these are, though. This is likely some kind of error that was occurring. So you'll notice that the GPS station was moving west, but also southward, because north, it would be going upward, but it's kind of heading down. So it was moving in some direction to the southwest, as well as slightly down. So this means the volcano was kind of not really moving up or down much, maybe on a slight deflationary trend. So if magma was to start flooding into the magma chamber, you might see an uptrend. This means the volcano is starting to inflate kind of like a balloon, but we're not seeing that. And you can play around with the other GPS stations as well. There's a lot of data to look at. So this is the website by the USGS for their volcano hazards information. So I like to use this website to get information about specific volcanoes, and if I'm interested, to look at the data. So the links to all these websites will be in the description, but let's move on to another website that deals with volcanoes. So this is another map I like to use for volcano information because it's not just limited to the United States and the USGS. This shows volcano information worldwide. So you'll see up here at the legend, it's kind of similar. Yellow means unrest, orange is warning, red means it's erupting. So you'll see that there's some eruptions happening worldwide right now. But if you click all, this is going to show pretty much all the volcanoes that they have on this website. I don't think this represents every single volcano on the planet, but it does show a good majority. Likely the ones that actually matter. If we zoom in here, you'll see that there's some black ones in the United States. So this is also showing extinct volcanoes, or ones that they believe are extinct. But let's look at something somewhere else in the world besides the United States. Let's zoom into Italy. Mount Etna should still be active. There it is, Mount Etna. Oh, there's another one off the coast. I wasn't familiar with that one. But let's click on Mount Etna. See, it'll give you some quick information. It'll tell you the type of volcano it is. It is a stratovolcano. Gives you the current elevation. And we can also view live data or webcam information. I'm actually going to click webcams, see what pops up. There doesn't seem to be much, well, to see right now. I believe this is a thermal image, so if it was erupting at night, you'd be able to tell that pretty easily. But instead I'm going to hit more. This will take you to their information webpage. I don't want notifications from them. And from here you can get a little bit more information as well as a cool picture. So I'll leave this website just as it is, pretty much what I use it for viewing and looking at volcanoes and volcanic activity worldwide. And finally, real quick, if you're really interested in GPS data, this is, again, specific to the United States. At least I think it is. Yeah, just the United States. It's USGS. If you want to look at GPS information, not just for volcanoes, but anywhere, use this website. So let's go to the Pacific Northwest. And you'll see there's GPS stations all over the place. I believe the color codes represent how frequently the data is recorded. So red, there shouldn't be any new data with this. Yeah, you'll see that it's discontinued. So for whatever reason, they're not recording any information anymore. But if you're interested in how the plate is moving and, well, how the surface of the Earth is moving, then this website is for you. Let's go down to California. This one should be interesting because it should be moving pretty significantly due to the major tectonic plate in the San Andreas Fault. And you'll see that the data goes all the way back to 2000 or before 2008. And these red lines represent earthquakes that have occurred, which can sometimes disrupt the trend in the GPS data, which is actually something we should be able to see in Hawaii, which there is none for this website. But I'll just leave that there.
All right, so those are the websites that I specifically like to use when monitoring earthquake activity, mainly in the United States, as well as when it comes to monitoring and looking at data involving volcanic activity. So I hope you find those websites useful as well, and maybe you'll start using them just as much as I have over the years. Specifically the earthquake map, I think I've been checking that thing every day almost for about a decade now. So I've gotten kind of good at recognizing patterns in earthquakes in the United States and recognizing swarms that are pretty typical of a region and earthquakes that seem to be a little less common of other regions. So I mentioned it earlier in the video, but I'll speak on it a little bit more. You may have heard there has been an increase in earthquake activity at Mount Adams. So whenever you hear like there's more earthquakes happening at a volcano, people tend to maybe get alarmed and concerned with what is occurring. But when it comes to Mount Adams, these are quite small earthquakes and the numbers are pretty low. I believe they only have detected or at least accurately located about 6 earthquakes in the initial swarm that got everyone's attention. 6 earthquakes occurring at any other volcano would not be something to be concerned about. I mean, earthquakes happen all the time at Mount St. Helens, which is one of the most active volcanoes in the Cascade Range, as well as various other volcanoes. But when it comes to Mount Adams in particular, Mount Adams is pretty seismically quiet. I believe its average is about 1 earthquake every 1 to 3 years. So to have 6 earthquakes like this, I believe they were saying it's the most earthquakes that have happened in the region since the 1980s. So it's quite the uptick in activity, you could say. There are also other events that are so small they can't accurately locate them, and that's because, well, there's only one seismometer at Mount Adams, which now there's more because they recently got temporary seismometers placed around the volcano to better monitor what's happening. But a lot of these earthquakes are so small, they can't accurately figure out where they're coming from, and they're also extremely shallow. So typically, if you have a volcano that's truly undergoing unrest, you're going to have hundreds, possibly thousands of earthquakes. And a lot of these earthquakes might start deep, associated with some kind of magmatic intrusion, and then gradually they might shallow as that magma is coming towards the surface. Or if the magma enters the magma chamber, you might get a lot of pressure changes associated with that intrusion, and it's going to cause tons of earthquake activity around the magma chamber and the surrounding area of the volcano. Also, with that, if you're getting magma intruding into a volcano, you're basically injecting all this new mass, and it has to it has to react somehow, right? So that magma is going to push up around the volcano, and it's going to cause uplift. And that uplift is detectable through different satellite or remote sensing monitoring systems. And after the 6 earthquakes that happened at Mount Adams, they did look at the ground deformation around Mount Adams or at Mount Adams, and no inflation was detected. So we have only 6 earthquakes that were located and a whole bunch of smaller ones. They're really shallow depths. There's no ground deformation at all. So I find it highly unlikely that these earthquakes are related to magma. I mean, it could be possible, but they're probably more related to possibly hydrothermal systems, maybe. I don't know. I feel like that could be unlikely too. My gut instinct on this is that they're related to maybe the mountains settling. So maybe there's some kind of shift in the rock, and it's causing a little bit of earthquake activity. Maybe there's some kind of fracturing. Of course, there's fracturing. That's what's causing the earthquake. But maybe there's some kind of slow creep of like as the mountain's settling. Maybe you're getting some kind of landslide like movement. Maybe. That makes sense. So volcanoes are not solid rock. They are piles of debris and lavas that are all kind of cemented together, and they're not very sound structures. Geologically speaking, they do not last long. They are torn down very quickly, and they are very unstable. And they also tend to get hydrothermally altered. So as you get hydrothermal systems altering the rock, you're basically altering that rock, and it's making it weaker. So you tend to break down the rock quicker, and this can make slopes of these volcanoes highly unstable. So you can have landslides at these volcanoes with no eruption at all. So you could just have a peaceful mountain one moment and then half the mountain sliding away or a portion of it because it's unstable without an eruption occurring. So maybe these earthquakes are more associated with some kind of settling related to weak rocks, perhaps. I don't know. But I don't think it's going to lead to any kind of volcanic activity. So that's just my little input on what is happening there. But it is exciting, and it is cool that they are monitoring it more closely to see if there are any notable things that might be recorded. But I feel like in a couple months we'll forget all about it, and Mount Adams will just go back to being the quiet little cascade volcano that no one thinks about much. So anyways, I hope you enjoyed this video. For all my subscribers that have been following me for a while on the channel, it's been a while since I've uploaded, so I'm hoping when I can to make videos. For those of you who don't know, or for those of you who do, I am a master's student, and I am in my final year, and I am extremely busy writing my thesis and doing my lab work. So this summer I collected a good number of samples and got those all processed and powdered. That was weeks of work getting those all prepped and got them shipped off to the lab, and I'm just waiting for my results, which I probably won't get back till the end of this year. So I guess what I'm saying is, don't expect a lot from me, unfortunately, in the next, like, half a year until after I graduate in May. So, yeah, I'll try to get things uploaded when I can. So, anyways, I hope you all enjoyed this video once again, and I will see you all in the next one, whenever that may be. So, you all take care, and until next time.